Okey-doke. So we're going to have a look at expanding, and then from there we're going to move on to factorising and have a look at how those two relate. So first thing we're going to do, expanding our brackets. So we use our distributive law. Basically what that means is that because this is 3 times 5 plus 2, the 3 applies to everything in there. So I can distribute it that way. So I'm going to do it 2 different ways and see if I get the same answer to have a look at the start. So this way I'm going to use my order of operations rule. So I've got 3, and we know that there's a times symbol in there. That's understood. Anything just next to the brackets is we multiply. So inside my brackets I have to do first according to my BOMDAS. So 5 plus 7, 5 plus 2, so I end up with 7. 3 times 7, obviously, 21. My distributive law means that I can apply that 3 to everything there. So these little lines there's my cap. Thank you, Luna. It's where I multiply. So it's 3 times 5. So 3 times 5, 15. And 3 times 2, 6. 15 plus 6 is 21. Happy days. Thank you, Lena. Professionalism of this outfit is off the charts. So both get 21. So this is just proving that it works. Right? And so basically, I can apply that to anything. So I again go 5 times 6 is 30. 5 times 7, 35. 30 plus 35 is 65. If I wanted to check, 6 plus 7 is 13. 13 times 5, 65. Alright, so that's how it works. So where we're going to start using it though is if you get something like that one. So, and you want to simplify that using the distributive law, or you want to expand those brackets. So again, I just do 5 times A, which is 5A, 5 times 6, which is 30. So that equals that. From there, you sort of, you can make it a little bit more complicated. If I had something like 5A take 3, same sort of thing applies. 5 times A is 5A. 5 times negative 3 is minus 15. Right? You won't step up in difficulty real quick, but when you do, you might have something like 5A outside of A plus 3, and so you go 5A times A, so that's 5 times A, which we know is A squared, and then we go 5A times 3, so that gives us 15A, because we're going to do 5 times 3 is 15. We've also got our A there. Alright, so that, same sort of thing. So you have 6B outside of B squared plus 9. Alright, 6B times B squared, we use our index law there. Alright, so when I'm multiplying, I'm going to, so my B squared, I end up with B to the power 3. 6B times 9, 6 times 9 is 54 with my B. Same sort of thing then applies with, excuse me, the minuses, and you'll work through those, but that's basically the, I guess the principle of it and how it works. We then go towards factorising. Now factorising is essentially the opposite. But people sometimes find it a bit more difficult because you need to know your times tables a bit better. So what I've got to do with something like this is that I've got to look and say, okay, what is the highest common factor with 5a and 45? So with these ones, it should be relatively simple, where you can go, well, I know straight away that there's a 5 in this one and 5 goes into this one. So what I do as a result of that is I know that it's going to be my 5 outside my bracket straight away. And then I divide each one by 5. Alright, and so I know that if there's anything on top and bottom, they cancel. So on this side I'm left with just A, and 45 divided by 5 is 9. Alright, that's my process. So what you'll notice, and here's one of the big kickers, and I hope you're watching this video because this is what you need to be able to explain with your exam, the relationship between factorising and expanding. It's exactly the same thing written in different forms. Alright, so there's factor form or expanded form. And you can always check, you shouldn't get any of these ones wrong because you can always check. So you go back the other way. 5 times A, 5a. 5 times 9, 45. Alright, so we'll do another simple one over here. 6a plus 18. Alright, so straight up I should be able to go, okay, well there's a 6 in this one and 6 goes into that, so 6 goes outside. Divide that by 6, I get A. Divide that by 6, I get 3. Right, and again I can test it. 6 times A plus 6 times 3 is 18. Where it gets excuse me, a little trickier is, say you have something like 4A plus 18. So immediately there I can look and go, well, 4 doesn't go into 18. So I've got to find, okay, what are my common factors between 4 and 18? And so something like that, I should be able to figure out pretty quickly that it's 2. So I put my 2 outside the brackets there. And again I divide that 1 by 2. 4 divided by 2 is 2. So on this side I'm left with 2a. 18 divided by 2 is 9. Alright, so there's my factor form for that one. And again I can test it. 2 times 2a is 4a. 2 times 9 is 18. That's basically your factorising. It's going to get a little bit more difficult as you go along, obviously. Excuse me. You're going to notice some things like, and let's just top of my head because I'm so organised. If I look at 14b, take 35. Alright, so straight up I'm going, okay, well I know they're not the same. I can't just, 14 doesn't go into 35, so I can't whack my 14 on the outside. So I have to find my highest common factor. If they don't jump out at you straight away, then you do your factor trees. And yeah, it might take a while to do, okay, but it's up to you about how well you do on exams and things like that. So our factor trees, we always start at 1, and then we go out 2. Does 2 go into 14? Yep, 2 times 7. Then I check 3. Can I do 14 divided by 3? Nope. 14 divided by 4? Nope. 14 divided by 5? Nope. 14 divided by 6? Nope. And I stop there. As soon as my next number comes up on this side, I know I stop. So now I do 35. I can do 1 and 35. I know that. Does it divide by 2? Nope. Divide by 3? Nope. 4? Nope. 5? Yep. 5 and 7? Does it divide by 6? Nope. And I stop because my 7's there. Now all I've got to do is look, okay, what's the biggest number that appears in both of these ones? And I know that it's 7. So my 7 goes outside here. I divide that one by 7. And again, 2b. I divide this one by 7 and I get 5, but I've got to be careful because I know that that's a minus there that time. Right, so again I can test my answer. 7 times 2b is 14b. 7 times negative 5, 35. This process is probably the key if things aren't jumping out at you first up. Alright, so I'll do one more where we have something like, let's go with 12c plus 40. Okay, so there's could be a few there. So I'm going to do my factor tree. I start with my 1, then I go 2. Yep, 2 and 6. What about 3? Yep, 3 and 4. I stop because I'm back to there. So there's no point going 4 down here because it's going to be 4 and 3, isn't it? Alright, so now what about 40? Well, I got 1 and 40. I got 2 and 20. Do I have 3? Nope. I got 4 and 10. I got 5 and 8. 6. No. 7. No. So I now go through and I look. My highest number in both of them is going to be 4. So my 4 goes outside my brackets. Right, 12 divided by 4 is 3. So 3c. 40 divided by 4 is 10. Other way, if you do it this way, your answers are sitting here looking at you. Look, yeah, see that? So once you've done that, you know that your answers are going to be there. So it's a bit of a foolproof way of doing it. It's a bit of a, you know, it sort of saves you a bit. That's my advice, is to do it that way, especially if they don't jump straight out of the page. Later on, and if you really want to give yourself a challenge, you won't be needing to do this in year 8, but if you really want to give yourself a challenge, you could, you know, throw in some letters. So something like, you'll get to the point where you have something like, let's say 15p squared plus 50p. Alright, and so you look at that one and go, oh yep, well I know that 5 is going to be my highest common factor, but I can also see a p in both of them. Alright, so p is a common factor. So I divide this one by 5p. So my 15 divided by 5 gives me 3, and I know that because of my index law, p squared divided by p, I get rid of one of those. So this side I'm left with 3p. Alright, p's cancel, 50 divided by 5 is 10. So that'll be that. As I say, that one's only a challenge if you you want to give yourself a challenge. If you're looking at that going, holy moly, then don't worry about that. You can worry about that one next year. In regards to where, you know, the age-old question, where am I going to use this? This one really is a precursor for the following years, because, you know, eventually you will start working with algebra that's quite complicated, that's quite large, and what you need to be able to do, the whole point of algebra is that we look to simplify things. And so sometimes you'll need it to be in this form in order to simplify it, because you'll end up factorising it even more based on that, and sometimes you'll need it to be in that form. So it really is just one of those ones that you're going to have to trust us that it's leading to you know, knowledge further down the road, but good luck with it, and I'll catch up with you soon. Bye.